Hi, I'm Finlay, the physics guy. Today I have with me 3 assistants, Jacqueline, Monica, and Madison. Today we're going to go out in the field and explore the physics behind the playground. Finlay, the physics guy. Finlay, the physics guy. Finlay, the physics guy.
Physics rules.
Finlay, the physics guy.
Inertia is a property of matter.
Finlay, the physics guy. Finlay, the physics guy. Hi. Physics is a science that deals with matter and energy and their interactions. Scientists use physics to predict the velocity needed for rockets to reach the moon, whether roller coasters are safe, and even how a baseball will travel once a bat hits it. Physics is the backbone to how and why objects move a certain way.
One major concept in physics is energy. When I'm standing at the top of this slide, I have gravitational potential energy. In other words, I have stored energy that has the potential to do an action. When I slide down, that gravitational potential energy is converted into kinetic energy, or energy that is in motion. Assuming that friction is negligible, I will have the same amount of kinetic energy as gravitational potential energy. Another major concept of physics is the conservation of angular momentum, which equals mass times radius times velocity. If angular momentum is conserved, then when my assistant's distance from the turning point, or radius, increases, her tangential velocity at a given time would decrease. In this situation, mass is constant, but if the radius is to decrease, then that means that my assistant's tangential velocity is going to increase.
If you want to learn how to master the balance beam, all you have to do is learn this simple physics principle, the center of mass. The center of mass is a point on the system representing the average mass. As long as my center of mass stays in line with this balance beam, I should have no problem staying on. But if I were to move my center of mass out of line, I would fall off. Whoa!
Hey guys, I'm sure you've noticed by now that I'm not going through this tree. This is because as I'm pushing on this tree is pushing back on me with an equal but opposite force. This is known as Newton's third law. Even if I exert more force on the tree and I will still be in equilibrium because the tree will still exert an equal but opposite force on me. Finlay, the physics guy.
Think of your center of mass.
The center of mass!
Nice, slide down.
Go!
Action.